The Earth's crust is thinner in this region, and the heat underground cooks the Thwaites Glacier from below, pushing it closer to collapse. West Antarctica is one of the fastest warming regions on Earth. As proof, you don't need to look past the Thwaites Glacier, also known as the Doomsday Glacier. Since the 1980s, Thwaites has lost an estimated 595 billion tons, 540 billion metric tons of ice, alone contributing 4% of the annual sea level rise during this period. The rate of ice loss from the glacier has accelerated dramatically over the past 3 decades. In part due to the hidden rivers of relatively warm seawater that flow through the bottom of the glacier, as well as absolute climate change that warms the air and the ocean. Now, new research suggests that warming oceans and the atmosphere aren't the only factors pushing Thwaites over the edge. Earth's heat can also kickstart West Antarctic glaciers. In a study, published this week in the journal Communications Earth and Environment, researchers analyzed data from geomagnetic fields in West Antarctica to create new maps of geothermal heat flux in the region. Essentially, maps that show the amount of heat inside the Earth heats up the South Pole. Scientists have found that the crust under West Antarctica is considerably thinner than in East Antarctica. About 10 to 15 miles, 17 to 25 kilometers, thick in the west versus about 25 miles, 40 kilometers, thick in the east. Exposing the Thwaites Glacier to much more geothermal heat than glaciers across the continent. Our measurements show that where the Earth's crust is only 17 to 25 kilometers thick, a geothermal heat flux of up to 150 milliwatts per square meter can occur under the Thwaites Glacier. Explained the lead author of the study Ricarda Giadec, a geophysicist at Alfred Wegener AWI and the Helmholtz Center for Polar and Marine Research in Germany. Fire in the hole. Because West Antarctica sits in an ocean trench, the crust below the seabed is much thinner than the crust below East Antarctica. Scientists have long suspected that this relatively thin crust must absorb more heat from the planet's upper mantle, which experiences average temperatures of 392 degrees Fahrenheit or 200 degrees Celsius, which affected the formation and evolution of glaciers during millions of years. In the new study, the researchers quantified this difference in heat flow for the first time. Using various magnetic field datasets, the team calculated the distance between the crust and the mantle at various points in Antarctica, as well as the relative heat flux in those areas. Study zone. It is difficult to say exactly how hot the glacier is where the ice meets the seabed, as different types of rocks conduct heat differently. However, it is clear that this additional heat input from the west can only mean bad news for Thwaites. Large amounts of geothermal heat can, for example, prevent the bottom of the glacier bed from freezing completely or the formation of a constant water film on its surface, said study co-author Carsten Goll, also a geologist at AWI. Any of these conditions could cause glacier ice to slide more easily on the ground, causing the loss of ice from the glacier to dramatically accelerate. Geothermal heat flux, lithospheric elastic thickness, and magnetic anomaly distribution of the Amundsen sea sector. A scenario like this could put the name of the Doomsday Glacier to the test. If it collapsed completely into the ocean, the global sea level would rise 25 inches, 65 centimeters, devastating coastal communities around the world. Additionally, without the glacier plugging the edge of the West Antarctic ice sheet like a cork in a wine bottle. Ice loss could dramatically accelerate across the region, leading to an unprecedented rise in sea level. Scientists will soon have the opportunity to further refine their measurements of heat flux under Antarctica. A major international research project is currently underway at the South Pole, including ice core drilling missions that extend to the bed of the Thwaites Glacier. Measurements of heat flux from these cores could give researchers a better idea of how much time is left, figuratively, in doomsday to trigger.